Hi, my name is Jacob. I'm a junior at Cornell University, and for the past few months, I've been working on this exhibit for the local physics bus. The physics bus is a science museum on wheels. It goes around showing off cool physics phenomena at local events and nearby elementary schools. This is what I built for the physics bus. I started with a record player. I used the record player as a base because I wanted something that could spin at a consistent speed for a long period of time. If I turn on the record player, we'll start to see it move in a circle. That's good. But you'll notice over here that this laser pointer moves back and forth in a line. So hopefully that's already a little bit interesting to you, that we're somehow transforming this circular motion through this mechanism right here into linear motion for the laser pointer. But that laser pointer is doing a very specific kind of linear motion. If I turn it on, you won't see much yet, but it's going to start shining on this glow-in-the-dark canvas. It's on my side. You can't see it yet. But I can make one more thing move on my exhibit. I can make this canvas start to rotate in a circle. And as I do that, start to picture in your head what it might look like on the canvas. I'm going to adjust this variable resistor to slowly change the speed of the gear motor that makes the canvas move. All right, and if I make it go as fast as possible, we get something like this. 1 second, let me get the lights. Take a second to admire it. I think it looks pretty cool, independent of any physics. It almost reminds me of those spirograph toys that you play with as a kid, where you have two gears of different sizes, and as a result, you get these kind of weaving patterns. Here, instead of two gears of different sizes, we have two motors spinning at different speeds, but it gives us a similar effect. All right, I'm going to start to adjust that variable resistor again to change the speed of the canvas. And as I slow it down, we're going to try to hit one very specific speed. Right about there. And as we give it a second for those older lines to fade out, we'll start to see exactly one line kind of take precedence over the rest of it. So what changed? Before we had a bunch of patterns, right? That spirograph toy kind of pattern. But now we only have one. It's because the motor on the record player is now spinning at exactly the same speed as the motor on the canvas. That means the laser pointer traces its own steps each time. It always returns back to where it came from. If you're a physicist, you might call this the first harmonic, because there's exactly one peak and one trough in the entire canvas. Let's try to get the next harmonic. I'm going to slow down the gear motor a little bit more, and hopefully we'll start to see a new pattern emerge. We're still trying to find this resonance where we always trace our own steps. But there's multiple ways to do that when you have a circularly moving pattern like this. And it's right around there. This one's a little bit hard to hit, so bear with me. We're right around there and wait for those older patterns to disappear. We start to see the second harmonic, where now there's two peaks, 1 and 2, 1 and 2. On the entire canvas, and there's two troughs as well. What's happening now is that the record player is spinning at twice the speed of the gear motor, exactly twice. In fact, we'd see a resonance pattern anytime the record player spins at an integer multiple speed. That means 1, 2, or 3 or 4 times the speed of the gear motor. Well, 1, 2, 3, or 4, etc. We could also do 0 times, although we'll get a kind of boring resonance pattern. Let's see what that looks like. And as the record player slows to a halt, we see what some might call the 0th harmonic, where the record player is spinning at 0 times the speed of the gear motor. It kind of just looks like a line. All right, let's turn the record player back on. Let's get that gear motor going fast again. What we see here has connections to all sorts of physics. At the very advanced level, This is almost how electrons work when they're orbiting a nucleus of an atom. It's also how different guitar strings play different notes. They have different resonating frequencies, which means that they have different distances between the peaks and the troughs. But even independent of all the physics that I could tie into this, I think it has value in and of itself. It draws pretty patterns, and I think that's enough. Thank you so much for letting me share this with you. Appreciate you watching.